Good day guys, welcome to another tutorial on CHN 101, and today we are treating redox reaction. By the end of this tutorial, you'll understand how to balance redox reaction and how to calculate oxidation numbers. So let's get right in. What is redox reaction? Redox reaction is this redox is gotten from oxidation reduction, shortened to form redox reaction. Oxidation reduction reduction reaction. That's what you call redox reactions, a reaction in which oxidation and reduction is going on simultaneously. So that's the redox reaction. And now let's also understand what oxidation is and what reduction is. Now, oxidation, there are so many definitions to oxidation and reduction. Well, I'm going to pick a few and the ones that we understand. Oxidation, actually, because you must be able to tell which side of the reaction is oxidation and which side of the reaction is reduction. So that's why we need to understand this. Oxidation means, one definition to oxidation, which is one of the simplest definition, is addition of oxygen, and it is simple and straightforward. And in the other side, it is removal of oxygen. That's for reduction. Now, another very simple definition to oxidation is removal of hydrogen, and then on the reduction side is the addition of hydrogen. Okay, these ones are actually the basic definition to oxidation and reduction. But let's go to something much more advanced. Now, when there is a gain, this is oxidation. When there is a loss of electron, then we term that as oxidation. And when there is a gain of electron, then we term that as reduction. And another definition again, which is another complex definition, is increase in oxidation number. And on this side is decrease in oxidation number. Okay. Now that takes us to oxidation number. What is oxidation number? Oxidation number is actually a number that tells the state of an atom or an element or a compound. It tells the state, it tells the charge that it carries with a specific number, which is usually arbitrary. It's a rule. Let me put it that way. It's just a rule based on some things. Is a rule. So you just need to understand it. And the simplest way of getting the oxidation number of an atom or an element is through its atomic number. So let me just pick a few and explain. Let's say, for example, what's the oxidation number of sodium? Firstly, what is the atomic number of sodium? Sodium is 11, isn't it? Usually written as this. So the atomic number is the number of proton. Let's not make a mistake. The atomic number is number of proton, not number of electrons. Okay, so the atomic number is 11, and if you have to do this, configure it based on the key element configuration, we have 281. Now this one hinders sodium from forming a stable electron. So sodium will prefer to lose this electron. Yeah, it will prefer to lose that electron and then have itself to be in this state. So remember, loss of electron is oxidation. Remember, so it prefers to lose electron, and once an atom loses electron, it becomes positively charged. And that seems plausible because if you know, if the number of electron and the number of electron is negatively charged, remember, so we can assume that in order for it to form an atom, it has to have same number of electron as same number of proton. So, and remember, proton is positively charged. So since it wants to attain stability, it needs to attain stability. In order to attain stability, it needs to lose one electron, isn't it? It loses one electron to become 10. Now, what is the overall charge here? +1. Yeah, that's why it is +1 here. So that's the oxidation number. That's how to get oxidation number of elements. So you can try for others. You can try oxygen. Oxygen is 8, right? 8. So that's 2, 6. Oxygen is 8, 16. So 2, 6. It needs 2 more to form a stable state. And remember, an atom is stable in 2 states, the octet state and the duplet state. So duplet state is if it has 2 electrons only in its outermost shell, which is the first shell, or if it has 8 electrons in its outermost shell. So, and in order for it to be stable, it needs to accept 2 more. It needs to accept 2 more electrons. Now, accepting 2 more electrons will reduce it to 0 or 2 minus. It will reduce it to O2 minus, and that 2 minus on top is the number of electrons it has accepted. Now, those are the rules, and there are so many other rules, and you can always follow them there in your notes. Just read them and understand. Now, I want to teach you how to calculate oxidation number. Now, oxidation number. How to calculate oxidation number of a substance in a compound, of an element in a compound. Let's take, for example, H2SO4. What is the oxidation number of sulfur in this compound? It's actually simple. Oxidation number means you need to know the valency of each and every element, because the valency has so much to do about the oxidation number of an element. So if you know the valency of an element, you know the oxidation number of the element. Now, what is the valency of hydrogen? The valency of hydrogen is +1. Hydrogen will rather lose that 1 electron that it has to form a stable compound. So it is +1. So the valency of hydrogen is +1. You must multiply it with its subscript because it has 2 there. So plus sulfur is actually what we are told to find, the oxidation number of sulfur. Now, what's the valency of oxygen, which is still the same as oxidation number? Remember, we've already done it earlier, which is what? Yeah, which is -2. And the overall charge here is 0 because there's nothing written. If you have something like this, this is the overall charge, is -1. So you write -1 out here, but since there's nothing here, it is what? 0. Yeah. So this is +2 plus S minus 8 equals to 0. S, by the time you bring this together, it becomes -6 equals to 0. Then X equals to 6. So the oxidation number of sulfur here is 6. And that is why you call this tetraoxosulfate 6. Yeah, I know you're like, ooh, that's where the 6 comes from. Yeah, that's where the 6 comes from. The 6 is the oxidation number of sulfur. That's why it is sulfate 6. Balancing redox reaction. Balancing redox reaction. To balance redox reaction is actually easy. It's more like balancing a normal reaction, but it's just that you have to take a little bit of things into consideration. So, balancing redox reaction, firstly, you balance redox reaction in 2 different mediums. You balance redox reaction in acidic medium, or you balance it in a basic medium. If you're balancing in acidic medium, it will be slightly different from balancing in a basic medium. Okay, so now let's start with balancing in an acidic medium. Now we have this, and you're told to balance it in an acidic medium. Yeah, balancing in an acidic medium. Firstly, we need to be able to, I'm going to kill 2 birds with a stone here. I'm going to explain how to determine the oxidation side and reduction side, and how to know the reducing agent and the oxidizing agent. So in fact, I'm killing 3 birds with a stone in this part. Firstly, let's know how to locate the oxidation side of the reaction and the reduction side of the reaction. The oxidation side, remember the definitions that we have given: addition of oxygen, removal of hydrogen, increase in oxidation number, loss of electron, and the likes. If we are to follow definition, we then say this. Firstly, if we are to follow the first definitions, we can term this one as reduction, isn't it? Since there's a loss of oxygen. Yeah, you're right. And we can term, we don't know what to term this. If we are following that, we don't know what to term. Should we term it? Nothing is removed. Nothing is being removed. Sorry, this way should be 3. Nothing is being removed. Nothing is being added. And you're like, well, but since you already know this is the reduction, then that automatically that's the oxidation. Yeah, you're right. Actually, you're right. You're definitely right. But in the reasons, I want you to think beyond just removal of oxygen and addition of hydrogen, because sometimes you might not even see hydrogen or oxygen there, and yet there's oxidation and there's reduction. Yes. Now let's first start with this. You notice that this is 2 plus, isn't it? And this is 3 plus. So iron goes from plus 2 to plus 3. There's an increase in the oxidation number. There's actually a table that they should have given you guys. They will give you guys definitely. Then you have plus 1, plus 2, plus 3, and so on. You have minus 1, minus 2, minus 3, and so on, like that. If it is going this way, it is oxidation. And if it is going this way, it is reduction. So it is going from plus 2 to plus 3, so it's going this way, so that's oxidation. So we can then say this is oxidation, whereas and then the other one here is the reduction. Fine. Yeah, but let us go beyond just removal of oxygen. Let's see beyond that. Now Mn manganese is the one that is carrying out the reduction here. So let's know the oxidation number of Mn here first, because the oxidation number of Mn here is not minus 1. The oxidation number of MnO4 is minus 1. So let's know the oxidation number of Mn. Remember, we've already done oxidation number, isn't it? How to calculate oxidation number. You're told to find the oxidation number of Mn. I'm solving it here. Mn is what we are looking for, so we don't need to touch that. Plus, what's the valency of oxygen? Minus 2. Minus 2 times 4. Then it has an overall charge of minus 1. It stays outside there, remember. So Mn plus, this is minus 8 equals to minus 1. So if it goes to that side, becomes Mn minus 1 plus 8 equals to 7. So we can see that Mn is going from plus 7 here to plus 2. And that's why that means it is going like this, from plus 7 up here down to plus 2. So reduction, we can see that it is reduction. So I always want you guys to see beyond just removal of oxygen, addition of hydrogen, and the likes. See beyond that. Okay. Now, since we've known the oxidation side and the reduction side, now let's now know the reducing agent and let's know the oxidizing agent. What is the reducing agent? What is the oxidizing agent? The reducing agent is the one that is being oxidized, and the oxidizing agent is the one that is reduced. Now, which of these two is the reducing agent? Which of these two is the oxidizing agent? Firstly, Fe2 plus is being oxidized to, we can see that it is being oxidized to Fe3 plus. So Fe2 plus goes to Fe3 plus. It is being oxidized. That means it is the reducing agent, because it is this one that reduces. Fe2 plus is the one that reduces MnO4 minus by losing one more electron to it, and itself being oxidized. So the one that is being oxidized is the reducing agent, and the one that is being reduced is the oxidizing agent. So MnO4 minus here is the oxidizing agent because it accepts electron from Fe2 plus. Then Fe2 plus becomes oxidized and itself becomes reduced, so it is the oxidizing agent. So the logic is that the one that is being reduced is the oxidizing agent and the one that is being oxidized is the reducing agent. So having said that, let's now go into balancing the redox reaction. Now, balancing redox reaction, the first thing to do is you split it into halves, the half reactions. You split them into half reactions. So you need to split the oxidation side and the reduction side out. So MnO4 minus goes to Mn2 plus, and you have the other side Fe2 plus goes to Fe3 plus. And then the next step is, if you have oxygen or hydrogen in the reaction, you balance them. And how do you balance oxygen? You balance oxygen by adding water, and you balance hydrogen by adding hydrogen ion. Okay, now there is oxygen in this place here. We need to balance it. And how do we balance it? You balance it by adding water, remember. So MnO4 minus, you need to add the equal amount of water that can balance this oxygen here. So that means I need to add 4 H2O because I have 4 oxygen here, oxygen ion here, and I need to add 4 water molecules such that water is balanced. But as I've such that oxygen is balanced, but as I've added water, I've added hydrogen, and I need to balance hydrogen. Balance hydrogen by adding hydrogen ion. So I need to add hydrogen ion to the other side to balance it. Now hydrogen is 8 here, so I need to make it also 8 here so that it's balanced. Now I have balanced the matter. I also need to balance the charge. Now the charge on this side, -1 plus 8 plus 2. We have plus 7 here, you have plus 2 here. And I need to balance the charge. I need to make them the same on both sides. So in order to balance the charge, all you need to do is add equal number of electrons that can balance both sides. The number of electrons that can make both sides balance. So electron, remember that electron is negatively charged. Remember, E minus. So I need to add 5 molecules of electron here to make it 2. I need to add 5 to this side plus 5 E minus. So by the time I add 5 E minus here, it becomes plus 2 here and also becomes plus 2 here. So in order for me to balance the charge, MnO4 minus plus 8H plus 5E minus Mn2 plus 4H2O. So it is balanced. This is balanced. Now let's balance this other side. Well, this other side doesn't really have much. We don't have a foreign element. So let's just go straight to balancing the charge. Balancing the charge means I just need to add 1 more electron to this side to make it 2 here and to make it 2 here, isn't it? So we are good. So E2E minus 2 Fe2 plus Fe3 plus E minus. Now it is balanced, so all we just need to do is compare these two, this one and this one, compare them and balance them if there's anything that is needed to be balanced, because we're going to combine everything into one. In the end, we can see that we have 5E here and we have 1E here. That's the only thing that isn't balanced on both sides. So in order to balance it, just multiply them with their respective coefficients. Multiply each half with the coefficient of their electron. So here is 5, so I need to put 5 here to multiply everything here, and here is just 1. 1 multiplies everything. So here at the end of the day it becomes F5 Fe2 plus 5 Fe3 plus 5 E minus, and if 1 multiplies here it remains the same. So we can then combine these two equations. You have, at the end of the day, you have MnO4 minus plus 8H plus 5E minus plus 5Fe2 plus. As I've written this side and this side, this side and this side. Now we need to write the other side. Mn2 plus 4H2O plus 5Fe3 plus 5E minus. So I can take out these two since they are the same, and we have our equation is balanced. MnO4 minus plus 8H plus 5Fe2 plus Mn2 plus 4H2O plus 5Fe3 plus. So it is balanced, and that is how to balance in an acidic medium. What if you are balancing in a basic medium? Basic medium, you are still following this whole process. Yes, everything that we have done so far, you're still following it, but when you get to this point, now let's rewrite this. For basic medium, you still follow basically what we have been doing for acidic medium, but when you get to this point, it doesn't stop here, it goes further. In order to balance in a basic medium, you must add equal amount of hydroxyl ion to balance hydrogen ion. So adding equal amount of hydroxyl ion, that means we need to add 8 moles of hydroxyl ion, isn't it? Then whatever you do on one side, you must do on the other, since it is an equation. So in the end, you have MnO4 minus plus 8H2O plus 5Fe2 plus, then produces Mn2 plus 4H2O plus 5Fe3 plus 8OH minus. Now we have water on both sides, so we have to reduce it. Since we have 4 molecules of water is common to both sides, so we need to reduce it. MnO4 minus plus 4H2O plus 5Fe2 plus Mn2 plus 5Fe3 plus 8OH minus. So you balanced it in a basic medium, and that brings us to the end of redox reaction. I hope you guys understand. If you have any question, please drop a comment. Don't forget to like and share this with your friend and subscribe. Please help me reach 500 subscribers before the end of this year. Thank you. God bless. Ciao.